Hey, everybody. Welcome to this Asterisk webinar. We're going to talk today about finding shadow agents and the identities behind them. I am Jonathan Sanderfield, CTO here at Asterisk Security, and I am joined by my good friend Tal. Tal, why don't you tell the people who you are?
Hi everyone. My name is Tal. I'm head of security research at Asterisk Security.
Beautiful. So here's what we're going to do today. First of all, we're going to talk a little bit about when AI became an agent, right? Not the kind that runs around Hollywood, but the kind that runs around your systems. We're going to define AI agents from an identity point of view. We're going to go over some new security considerations this model gives you. We're going to talk about a potential part of a solution, our fingerprinting techniques. And then we're just going to talk about some best practices. Everybody likes best practices, right? But let's begin at the beginning, right? When did AI become an agent? And Tal, you tell me, what do you think is the key to that transition?
Yeah, so everyone has been talking to their friendly chat assistant in the past 2 years or so. And a few months ago, everyone started to talk about an AI agent doing stuff for you. And this is exactly the crux of the name. When those friendly chat assistants were actually given the agency to do actions on your behalf or pull data on your behalf, then they became AI agents. So this transition happened when we gave the chat assistants tools, basically. Tools is a common name for this ability. Also, sometimes called actions.
Now, give me an example of a tool. Like what would what's a simple example of a tool that some AI assistant might use to therefore become an agent?
Right. Everyone hates going over their emails at the beginning of the day. And you
Hmm.
could have your chat assistant, instead of you doing it manually, go over your emails and summarize them. So you gave it the access, the tool to read your emails. Then you can do that, and maybe in the future even reply to those emails. Maybe do it for the entire company, so nobody needs to work anymore. But yeah, that's a simple example for an agent.
I wish my job was just replying to emails and I could have an
Yeah,
AI
right.
do it, but doesn't seem like that's actually the world we live in. But it gets a lot more complicated than that, right? So I mean, obviously, when you're talking about that sort of thing, giving it, you already used the phrase, giving it access to your emails, right? So we're already building this idea of access into this. So if we're going to think about these agents, right? What's the makeup of an agent, right? Like, what are the components that you would imagine?
Yeah, you can take an agent, like break it apart and like look into the behind the scenes of how it works. And generally, you can split it to three different organs, let's call them. So you have the part that is in charge of interacting with the user, right? So in like when you think about the AI assistants, you have this chat interface that basically allows the agents to talk to some end user and ask for confirmation and get its prompt, etc. There's also the piece that's usually baked into the whole agentic systems that allows the LLM that incorporates LLM into the entire system. And then finally, so these two pieces are just what makes a chat assistant. But if you give the chat assistants the ability to use tools or call actions, and that way access different resources, either read them to use as additional context or also do actions on your behalf, then it becomes an agent, right?
So, what's interesting to me about this is the distinction a lot of people don't seem to get is that an agent is not the LLM. The LLM is something the agent utilizes, but it is not that. So, in a sense, the LLM is kind of like another tool for the agent, right? The agent is a program. It uses the LLM to do inference, but then it's going to have these other tools that'll allow it to do other things with that inference. Is that a fair way to characterize that?
Definitely, it's the power of combining the two things that makes the agents what they are today. We could have written some algorithm before we had very good LLM systems that interact with the user and does some actions on like according to what the user tells you. But our problem was always using natural language to do it. Right? This is the
Right.
magic of AI agents.
Right. So the other thing that I think is interesting here is that now we're talking about other kinds of agents entering the picture, right? And obviously, we just changed the picture a little bit. What is the major change that just happened, and why is it significant?
We remove the user interaction from the system, and this is usually being referred as an agentic system, which has almost full autonomy to work. It gets like an initial context, maybe an initial prompt, and then it can have the autonomy to run on its own for however long it needed to do the task that it was told to do. Um, and that's the difference between an AI agent and an agentic system. And we see those kind of autonomous systems gaining more and more popularity as we go along, because they're way more powerful than needing to keep the human in the loop.
And if I could tie that to the theme here, I imagine identity becomes even more important in these autonomous agentic systems, because now the human's identity isn't the one that did the thing. You didn't have it summarize your emails and talk to you about what to do about each one. You had to go just do all the things, and so it really had an identity of its own in that sense. Is that a fair
Yeah,
way to
when,
put it?
when, when you break up the action, the part even further, behind it lies some sort of access through some identity. And when you have an AI agent, many times you kind of have to rely on the identity of the human in the loop to do these actions. But when you let the system run autonomously, you have to create a new identity, new types of access for the agentic system to do its necessary actions and use its necessary tools.
So when we think about that tool use, right, I imagine the identity and the action are very linked. And I know it's been let's say a little basic in the past, right? So
Right.
I think this is an example of one of those very basic things. Tell the people what they're looking at and why it's significant.
Yeah, so actually AI agents are not, we only recently starting to hear about them more and more, but they are not a new thing. So even just after the inception of ChatGPT, OpenAI thought about this very strong ability of allowing your agents, in this case GPT, to do actions on your behalf. So they created what's called custom GPT, which allowed developers within your organization to give an open API schema to the new custom GPT, and then it would be able to understand the API that it is able to interact with, basically exposing the different actions and tools that it can do, and makes it way more powerful than it is. And you can see there's a tiny piece above the open API schema. There's the part of the authentication, actually granting the identity to the custom GPT. They support multiple ways to do it, either by OAuth or by giving it just an access key.
Including apparently none, which I imagine our audience is probably the most frightening option of all, right?
Right. If you have the
unauthenticated
API,
call, right?
Yeah.
But I imagine this gets messy very quickly, right? Because now your agent has the same problem that all your code always had, managing all these APIs, the specifications for each, understanding the different schemas, perhaps having to meld and transform data. Anybody old enough like to remember XSLT will have the nightmares that I'm thinking of right now, back in the XML days. So I think we have a hero in this story that comes along and decides to do something different, right? So tell us a little bit about Anthropic and MCP and how it relates to this story.
Yeah, so thankfully for all of us, so custom GPT didn't really catch on as much as probably OpenAPI wanted to, but Anthropic came forward with a new type of protocol that allows this making tools available for AI agents, which is MCP, which you have probably heard about. It was released about half a year ago, kind of together with the rise of the name of AI agents for an obvious reason. This basically brought agents for the masses, and the way that it did it is by actually the problem in the first place is that you had to implement every API that you needed access to, and give this implementation to and expose this implementation to the agent in some way. And MCP, the protocol itself, decoupled it. So now you can offload this work of implementing all the different APIs to some developers. So the open source community really took MCP by storm, and everyone developed their own MCP servers. But your model, the LLM, the agent, only needs to know how to talk with an MCP server. So this decoupling makes the whole systems very easy, because your agent can talk with one protocol to all the MCP servers being deployed by developers around the world without needing to create distinct interfaces to each one of them.
I mean, it's right there in the name, right? It's a protocol for
Mhm.
giving your model context as it interacts with tools, right? Model context
Yeah.
protocol. And the other thing that I think was very cool about what happened here is that since, you know, these API wrappers became standardized, you also had this rise of a sort of standardized ecosystem, right? Tell us a little bit about that.
So a few months after MCP came out, developers started making open source contributions to this project, creating a lot of different servers. We started seeing databases indexing all the different MCP servers available to you, starting to pop up everywhere. And you can see just an image from one of the most common marketplaces, indexing 15,000 different servers. And actually, by if you kind of look at the different servers and then their implementation, you might realize that really just a fancy API wrappers.
Mm-hmm.
And it was exactly like with providing your agent with an open API schema, except now you offload the task of providing the relevant tools for your agents to a developer, giving your agent access to different tools using natural language as well, which is much stronger than giving it the entire open API schema, which usually is too long and too so LLM knows natural language. OpenAI schema is not usually giving in natural language. So this was the power of MCP, and the fact that they are just an glorified API wrappers and this decoupling begs the question: where is the identity in the
Yeah,
whole
and
thing?
I'll point out, like, glorified API wrapper sounds like a bad thing, but to those listening, remember, I guess what would this qualify as, a seventh generation language, MCP or something like that, right? But if you trace back everything, everything's just a wrapper to basic math, right? I mean, CPU CPU calls are a wrapper to basic math, and then low level programming languages wrap that, and so on and so forth. So this is the natural progression of things. But to your point, every time you have wrappers, you have abstractions, right? And those abstractions then can carry other things with them, and that leads to the model for MCP from an identity point of view, which you were just thinking about. How does this impact our identity theme?
Yeah, and you can see on the image, so you have what happened before and what happened after. You have this MCP in the middle between the LLM and the different APIs that it uses, which is to say the LLM will be, in the official terms of MCP, the MCP client, and it talks with a unified API with all of its MCP servers, which in turn they are just API wrappers. But to call an API, you need authentication. You wouldn't put the authentication on the MCP client, because it really doesn't know anything about the actual APIs. Right? It's beyond a nice wrapping with natural language, providing it with the ability to do calls. So the only place that the identity can live in is actually on the MCP servers themselves. They are the one in charge of using this, of getting this identity, getting this access, and using it to call the different APIs that they want to expose to the MCP client. So the identity is really in that tiny piece of the server between the LLM and the APIs and the different tools that it uses.
And thank you to our friends at Dscope for the image. Now, if we want to dig into this a little bit, right? Obviously, the MCP server has the identity, but that implies that there are a lot of things happening at that MCP server where that identity is carried. what are the important things that people should understand about the relationship here?
You can think about the progression of how an MCP server is deployed, right? Someone wants their client, maybe their Claude on their local machine, to access their GitHub for them, and I don't know, read issues or open pull requests and stuff like that. So the first stage is actually creating this identity. And usually what happens is that MCP server developers kind of honed in on a specific type of usually non-human identity that they need access to in order to do their actions. And you go as the one deploying the new server, you generate a new identity. Hopefully it's very distinct and obvious that this is used by your agent. You provide it to your MCP server, usually by altering the configuration of the server, and then it can use it to call different APIs. And the MCP server has to have this authorization in order to call the API, which in my view kind of points the fact that it has an identity as one of the top security related priorities when it comes to MCP server deployments. You also have to, of course, be mindful not to download some unknown, unreviewed MCP server from the internet because, well, it can contain malicious code, but for this you have the different indexes and you have reviews and stars, and the open source community really puts a lot of emphasis into not letting stuff fall beyond the cracks. What they don't do, and it's entirely up to you or the one deploying the MCP servers for their agents, is handling the identity. And the fact that it's kind of hidden somewhere in the configuration, it's only generated once, it's usually a very long-lived token belonging to some non-human identities sometimes it's even a long-lived token related to some user in your organization, human user in your organization, really makes it a problematic piece that a lot of people, and our listeners in particular, need to be very mindful of when they allow people to deploy agents, deploy MCP servers, and by proxy agents in their environments.
I mean, anybody who looked at the screen and didn't instantly shudder at the idea of a personal access token being embedded in a server component, right? It's right there, and I think a lot of people probably didn't. But I think you're starting to raise some interesting security considerations. Naturally, that leads us to all the different security considerations. I'm gonna list these off, and then I'm gonna ask you about each one, right? So, first of all, I think it's interesting to understand that these AI agents are not predictable, right? Why is that important? Well, we're used to programs behaving in understood ways. The second is you might have very sensitive permissions that are now going to be leaving your direct control, especially if you're stuffing your personal access tokens into these servers. Again, this actually presents new opportunities for living off the land attacks, and I'll let you tell the audience what that's going to mean. And all of this adds up to the exponentiation of the non-human identity problem, the increasing load of NHIs in organizations. But let's go through each one of these. So first of all, agents are not predictable, right? Now, predictability makes security people feel good. Obviously, this is the opposite of that. Where's the main concern here? What should people be thinking about?
We just said that the most common way to grant agents with becoming an agent and granting it access is usually made through non-human identities. And when you do your non-human identity program, one of the things and this is very hard in general, but one thing that really makes it a bit easier is that for non-human identities compared to human identities at least, they're very predictable. They're usually used by a very predictable algorithm on some workload somewhere.
Right.
It behaves the same way throughout many different times that it is executed. But now you kind of combine the worst of both worlds. So you have the unpredictability of an agent, of an LLM doing actions that you can't really foresee in advance, together with the difficult world of non-human identities, where you have server developers that didn't really put a lot of attention into the specific types of non-human identities and choosing the best one for their action. They're just and fast adoption really puts a strain on this as well. Everyone wants to develop a new MCP servers. They don't really think about what's the best non-human identity to use for this type of agents. And this non-predictability leads it is a very major security consideration, because you have to maybe alter the way that you even think about non-human entities, and the entire process in your organization that starts from someone needing a non-human identities, generating the new identity, generating the credentials, then using this credentials somewhere. This might look completely different in the world of AI agents.
And I'll just point out too that this non-predictability, it is a problem from the security practitioner's point of view, but it can actually be the solution or a major part of it in the eyes of the person who's deploying the agent. And the reason I say that is, I've worked with companies that build these agent platforms, and as you plug in new, better LLMs or more powerful LLMs, they might decide to do things in different ways because they figure out a better pattern. That's a good thing, right? Until you're trying to predict them, right? So this is built into the way this works, right? You can't escape it. Now, the next idea, right, is this sensitive permission sprawl, right? Obviously, if I want the agent to do something that has sensitive permissions, I have to give the agent those permissions. How does that lead to sprawl, though?
So you have two major cases when it comes to agents. The first one is the agent that we usually think about as the first iteration of agents, your personal assistant. So we imagine that every employee in the future workspace, and even today, would have their personal assistant as an AI agent. And suddenly you have some NHI, some non-human identities that belongs to this agent that needs the exact same permissions that a human does, which is crazy to think about. Usually, when you think about non-human identities, you think about a very, very specific set of actions that it needs to do. But now you don't know in advance anything because it needs to be an assistant to some employee, so it needs the exact same permissions, which leads to a huge permission sprawl, which we also think about. Usually, you have some, I don't know, code that does something, then it only needs access to maybe one, two different resource platforms, but with an agent, especially an agent belonging as a personal assistant to some human, needs access to all of your environments at once. That's one issue, and the second issue stems from the first problem. You don't know how to predict, even if it's not like a personal assistant to some human, because you don't know how to predict what actions will be taken by the agents. You kind of have to give the agent a bit more permissions that you would use to, because you don't know how it will react. You changed models, now the agent wants to do something different, needs more permission. This very easily leads to a sprawl of permissions.
Yeah, and it's the tension between those two cases that's always interesting to me. The OBO case, right, on behalf of, right, where and you see standards even that deal with OBO, but there's that other case, sort of the classic service accounting that we've never had a good name for, where it's doing something for the benefit of a person, right? So it's doing because Tal needs it to be done, but it's doing it with permissions potentially that I never want Tal to have, right? I don't want to grant you that permission, but I need to grant this agent that permission so it can do this for you, right? So it gets really crazy really quick. Now, the living off the land attack is not new, but these agents give it a new spin, right? So I'm not going to steal your thunder. Tell the audience about it.
Sure. So living off the land, it's a classic technique used by attackers for many years now. Well, they kind of understood that different programs trying to capture them, like EDR, antivirus, etc., this kind of software, kind of relies on the attackers doing things unnaturally, coming with their own tools, doing stuff their way, and not the way that the machine usually behaves. And this spawned a whole set of attacks named Living Off the Land, which basically says you're an attacker, you read some machine, you only use the things that are already embedded on the machine in order to progress your attacks. And of course, this, if the machine is very limited in what it is able to do, in what already exists over there, then the attacker also is very limited. But we've seen attackers really utilize this to their benefit for a lot of time. And now, when you have those AI agents existing on different machines, this kind of gives a very wide array of living of the land attacks for threat actor, where they basically can communicate with the agent just like any human would, and make them do actions on their behalf, and it wouldn't look as weird to any software that is intended to block this.
Yeah, I mean, basically, that unpredictability becomes a friend of the attacker, right?
Exactly.
That's the basic idea. Not the best scenario.
Yeah.
So I think this one, right, if we really think this through, is a consequence of the rest, right? As we expect AI agents to outnumber humans, right, if everyone's got a couple of them, what we're expecting then is the access, and therefore the identities that grant that access for those agents to also begin to grow, right? So that means all the problems that we're talking about are multiplied by that number, right? What specific things do you think this impacts?
So I think that the fact that you would have an agent per employee in your organization, and you have agents needing access to many different platforms, to many different NHIs, makes the ratio grow even more that we've seen today compared to humans. And the impact is kind of obvious, right? You're going to have a lot more NHIs to cover. You now have to have way wider context about those NHIs. It's not enough to say, well, this NHI is using this and that automated process. Now it's part of an agent and does stuff unpredictably and connects between different NHI. So your NHI related to GitHub can affect your NHI related to Slack because it's used by the same AI agents, just for an example, makes the entire thing much harder to control for organizations.
So as we think about that, I think a natural question everyone's going to have is, all right, well, if these things are going to start proliferating everywhere, if I'm going to have them everywhere, how do I find them, right? Like, what is the way that I can know if they're out there? Because I don't know really if, like, if I have this person, Danielle, and Danielle is going to go and build an agent because her Gmail allows her to, and I don't have any way to block that really. What am I going to do to find that, right? So I know you have some ideas about how people can essentially figure out that agents are at work, these fingerprinting techniques. So let's walk people through these techniques. It's not, the full power of something to help you, but it is something that you can use with what you've got, right? So
yeah, and it's extremely important because MCP got so popular, which is great for the AI agents community.
Right.
But it's also the problem of basically allowing anyone in the organization to create a new agent. So even more than normally needed for your non-human identity program, understanding which NHIs exist and which are related to your agents is crucial. And our techniques will mostly focus on how you can detect using the different tools at your disposal as an IAM administrator or just an identity security person to find those identities, because they can be just a personal access token that someone created in their GitHub account. You have no way of viewing that directly. So we're going to focus on like side channel information that is being accessed. So the first technique that is very useful and very strong is actually relying on information given to you by the different AI agent companies. So you can see an image taken from the OpenAI website, and you also have those for every other company, Anthropic, Perplexity, anyone. They usually post their egress ranges for IP addresses, and you can use them to detect when someone from some agent from these companies accesses your non-human entities. You see a non-human entities doing some action from these IP addresses, which is a very strong technique. The second one is relying on official OAuth apps. So a lot of, they usually call them connectors, but they're in fact just a very limited set of tools, not extendable like MCP, but a lot of different agents really allow you a very quick way to deploy a new tool using official apps, usually built on OAuth, Those OAuth have a unique identifier. You can basically check this and see who in your organization actually granted those OAuth access, and you can detect those agents that way. Those are different kind of agents, like those are agents that are built into the different systems. Then you have a very, very strong technique, mostly related to open source code. So many open source projects use their distinct user agent, especially when it comes to MCP. It's kind of requested by the MCP specification. If you develop an MCP server and you didn't do it, please do it. Makes our job easier. You can rely on user agent. You can see two examples for very, very well-known MCP servers. One is GitHub, the other one is Azure, and they have a very distinctive user agent. You can sign on and see it popping up, but used by different non-human identities.
So before we go to our overall sort of best practice advice, how would someone implement these fingerprinting techniques today, right? I mean, obviously there's one obvious answer in the lower left-hand corner of the slide, but if they don't have tooling like that, right, they don't have an asterisk in their life already, how would they implement these sorts of things?
Most platforms still provide you a quite extensive set of logging and audit capabilities, and usually through that, especially if there are also action based logs, which actually show you what the action being taken. This is the best case scenario. You can use the data, the IP addresses, the user agent, the distinct identifiers of the non-human identities being used to capture all the different agents that exist, and then decide on the approach that you want to take. So you can take a lot of many sets of approaches. You can, if you don't want those agents popping up without you knowing, you can restrict the IP addresses from which they're used. You can restrict the user agent. You can restrict these actions. And even if you do want to allow them, now you have a way to pinpoint them and take a closer look at their behavior, what they do, the permission, and do the entire lifecycle management of those non-human identities.
Cool. So last but not least, what are some measures that people can take? Like you said, using the user agent for a developer of an MCP server will make all of our lives easier, but what are the things that people can do to make their own lives easier as they're deploying their agents?
Yeah, and these points are directly related to the different security consideration that we mentioned, right? Only in the sense of what you should actually do. So once you detect a non-human identity is related to an agent, tag it. Have some way to come back to it in the future and see that yes, this NHI is related to this AI agent. Allow your users to tag it themselves if they are willing to, or if you force them to. After you have detected an NHI belongs to some agent, you can actually go and talk to the agent owner and understand what the agent behavior is supposed to do. We know this is unpredictable, but you can still sort of encompass all the different things that you might think this agent will do and restrict the permission further to avoid permission sprawl and the problem with the unpredictability. It can actually be mitigated that way. Also make sure this NHI is not reused. It's very, very tempting to reuse the NHI. You create it once, you deploy 10 different MCP servers of the same, for multiple agents, but the same MCP server. It's very tempting to use the same NHI. Don't do it. If you are afraid that your employees will, you can use techniques just like IP restrictions to force them to use different kind of non-human entities or other kind of restrictions based on the agent's attributes. And lastly, ownership is key here. If you know the human that is in charge of an AI agent, you also know this human is in charge of the non-human identities, and you can make sure that you have those life cycles in order for the non-human identities.
Yeah, I mean, several times as you've been talking, you've mentioned the owner, right? So having to have that owner is built into a lot of these considerations.
Right.
All right, so Tal, thank you so much, right? Let's talk a little bit about what people could do next if they want to. If you're very excited about everything Tal had to say and minimally interested in some of the things I might have said, you can take some next steps here, right? So we've got some papers about agentic AI security that you can use to learn more. We've also had some deeper research done by Tal's team about the touch points between AI and NHI. So if you want to dive deeper into that on the technical side, that's the middle thing. And if you want to watch even more video content, you can watch how attackers exploit NHIs. One of our engineers gets deep into that in that video. I'll say once again, thank you, Tal, for all of the great information and putting up with my blubbering during your great information. And I hope the audience has gotten something good out of this. Thanks for your time.